Hello, scholars. This is Mr. Lowe. Coming with you is lesson 5 in our pre-skills unit focusing on integers. So we're going to focus on some of the basic concepts associated with integers, along with going through adding, subtracting, multiplying, and dividing. So again, this is the 5th lesson in our pre-skills unit. So with integers, so far we've dealt primarily with all positive numbers. So now we're going to deal with positive numbers, negative numbers, and 0, which taken together are referred to as integers. So as you can see, looking at the number line, the 0 serves as the dividing line, so to speak. To the left of 0 are your negative numbers. To the right of 0 are your positives. So a couple things that we need to keep in mind as we're working with positive and negative numbers are how to compare them. First order of business, a negative number is always less than a positive number. Negative number is always less than a positive number. So when you're comparing -9 and +2, -9 is smaller. So that's the sign that you would use to indicate that -9 is less than 2. Another example, 5 and -3. So 5 is the bigger number. So 5 is greater than -3. When we're working with just positive numbers get larger the farther away you get from 0. So this is basically the standard operating procedure that you've been working with the majority of your mathematical life. 14 and 30. 30 is obviously the bigger number. 19 and 7. 19 is the bigger number. Now, when we switch over to negative numbers get smaller the farther away you get from 0. Farther away you get from 0. So if you use this number line that's sitting at the top, -2 would be bigger than -8. -8 is smaller because it's farther away from 0. With that being said, -4 and -11, -4 would be closer to 0 than -11 would. So a greater than sign would be used to indicate that relationship. -14 and -8. -8 would be closer to 0. So a less than sign would be used to indicate that. So that's comparing integers. Again, a negative number is always smaller than a positive. Positive numbers get bigger the farther to the right that you go. Negative numbers get smaller the farther to the left that you go. Now, as far as putting numbers in order, so if you have to write numbers in order, there is a certain way that you would do it. So you always start with your negative numbers first, then 0 if you have it, then your positive numbers. So let's first start with our negative numbers in this list. So we have -1 and -1.5. So the smaller of those numbers would go first. So that would be -1.5, with -1 coming up behind it. Then you would insert your 0. So we have a 0 in this list, so that would go next. Then we work with our positive numbers. So our positive numbers, you have 1/4, 7/5, and 0.3. 1/4, 7/5, and 0.3. So we would put those 3 numbers in order from least to greatest. So if it helps for you to write these as decimals, that's okay. 1/4 is the same thing as 0.25. 7/5 is the same thing as 1.2. So looking at it from that aspect, the next number would be 1/4, followed by 0.3, and then followed by 7/5. So that gives you your order from least to greatest of your numbers. Again, negative numbers go first, then 0, and then your positive numbers when you're putting them in order. So that's our first order of business with regards to integers, working with how to compare them, which one is bigger than the other. Now, of course, integers create two new mathematical operations, that being an opposite and an absolute value. So opposite of a number is simply the number that's on the other side of 0. Same number, just on the other side. So the opposite of a positive number would be a negative number. So if you have 3, the opposite would be equal to negative 3. 5/4, positive 5/4, the opposite would be negative 5/4. So notice that for a fraction, I did not make the top and the bottom negative, I only made one part negative. You only need one part of it to be negative. Conversely, the opposite of a negative number is a positive number. So negative 3.7, the opposite would be 3.7. Negative 8, the opposite would be a positive 8. So very simple, straightforward. Opposite, you're simply changing the sign. Absolute value of a number is a number's distance from 0. So this is something that we touched upon earlier in our pre-skills unit. The absolute value of a number is always positive. Is always positive. And remember, for notation's sake, the absolute value of a number would be the double bars with a number inside of it. Double bars with a number inside. So for example 1, if you're looking for the absolute value of 9, that would be 9 inside of the double bars. You're looking for how far is the number 9 from 0. That's 9 units. Absolute value of negative 10.4, so that's negative 10.4 inside the double bars. 10.4. Absolute value of negative 12, so negative 12 inside the double bars, that's 12. And negative 11/4, so the absolute value of negative 11/4 is 11/4. So again, the absolute value of a number is always positive. Remember, when we looked at absolute value, there is one exception to this rule, so let's revisit that. So if you have a minus sign and then the absolute value of a number. So this is read as the opposite. That minus sign out there represents the opposite of all of this. Absolute value of negative 6. The opposite of the absolute value of negative 6. So this is what that expression represents. So to solve it out, just like we went over last time, a while back, do the absolute value first. So the absolute value of negative 6 would be 6. And then the opposite of that, so the opposite of 6. So now this is telling you to do the opposite of 6, which would be negative 6. So again, understanding the symbolism, the notation, how it works will make it pretty easy for you to solve out the problem. So now we've addressed opposite and absolute value. We've addressed comparing and ordering integers. So now we can go ahead into the computation phase with positive and negative numbers. So let's start with adding. Let's start off with adding. So for adding, there are two different scenarios. The signs are the same, the signs are different. So the signs being the same means you have two positives, a positive plus a positive, or a negative plus a negative. So if the signs are the same, add the numbers, keep the sign. Add the numbers, keep the sign. So 9 plus 6, so that's a positive plus a positive. So 9 plus 6 is 15. Positive plus a positive stays positive. Negative 2/5, 2 over 15 plus negative 5 over 9. Just because they are fractions doesn't change the rules. Just because it's a fraction, it doesn't change the rules. So you have a negative plus a negative. So we need to add those numbers up. 2 over 15 plus 5 over 9. Again, you need common denominators. First number that they share is 45. So 3 times 15 gives you 45. So 3 times 2 gives you 6. 9 times 5 gives you 45. 5 times 5 is 25. So 31 over 45. So you have 31 over 45. Add the numbers up, and you keep the sign. Add the numbers up, and you keep the sign. Just because it's a fraction, they were two fractions, doesn't mean that the problem doesn't get done. The problem still gets done the same way. So it's the same sign. These are the rules for if the signs are the same. If the signs are different, then the rules change up a little bit. If the signs are different, meaning positive plus a negative or vice versa. So step 1, ignore the signs on both numbers and subtract the numbers. So 17 plus negative 3. So that's a positive plus a negative. First off, ignore the signs and just subtract. 17 minus 3 is 14. So step 2, keep the sign from the bigger number. Keep the sign from the bigger number. So you have a 17 and you have a 3. 17's the bigger number, and it was positive. So this would stay as a positive answer. So you don't have to put plus 14. You can simply write 14, and that's good enough. You can simply write 14, and that's good enough. So example 4, same rules apply. You have a negative plus a positive. You have a negative plus a positive. So you ignore the signs and subtract the numbers. 18.6 minus 11.9. So this does require a little bit of borrowing. So again, we're working with decimals. Decimals are numbers too. So this gives you 6.7. Now you look at the two numbers. 18.6 is a bigger number than 11.9, and it had a negative sign in front of it. So that means your answer is going to be negative. So you ignore the signs first and just subtract the numbers. Then you look at which number was bigger. Whichever number was bigger, that's the sign that carries over. So it is a two-step process when the signs are different. It is a two-step process when the signs are different. So that's what we do as it relates to adding. That's what we do as it relates to adding. Subtracting. So subtracting follows the mindset of keep, change, change. Keep, change, change. So you keep the first number, change subtraction to addition, and then change the second number to its opposite. Once you keep, change, change, then you follow the rules for addition because you just changed it to an adding problem. So example 5, 7 minus 12, you would keep the first number, change subtraction to addition, and then change the second number to its opposite. So the opposite of positive 12 would be negative 12. Once you rewrite it, then you solve it. So 7 plus negative 12, you have a positive plus a negative. 12 minus 7 is 5. 12 is the bigger number, negative 5. That's how the keep, change, change mindset works. Example 6, 7 over 30 minus negative 11 over 30. Keep the first number, change subtraction to addition, change the second number to its opposite. So the opposite of negative is positive. So again, just because it was fractions doesn't change how you solve the problem. The denominator is the same. So keep the denominator, add the numerators up. 18 over 30. Both of those you can divide by 6. So you get 3 over 5. So you get 3 over 5. Again, just because they're fractions doesn't change the rules up. It just means you have to follow the rules for fractions as well. Example 7. Keep the first number, change subtraction to addition, change the second number to its opposite, so that becomes positive 1. So we're at negative 9 plus 1. So 9 minus 1 is 8. The bigger number was negative. So negative 8 is your final answer. Then lastly, negative 19.2 minus 4.4. Keep the first number, change subtraction to addition, change the second number to its opposite. So you're adding two negative numbers, so that just means add the numbers up. 19.2 plus 4.4 is 23.6. Since both numbers were negative, the answer stays negative. Since both numbers were negative, the answer stays negative. So that takes us through subtraction. Main thing with subtraction is the idea of keep, change, change. Not to be confused with dividing fractions, that's keep, change, flip. So make sure that you keep the rules separate. Keep the rules separate. So we've done adding, we've done subtracting. The nice part about multiplying and dividing is that they follow the same rules. Multiplying and dividing follows the same rules. So with multiplying and dividing, you multiply or divide as you normally would. If the numbers have the same sign, the answer is positive. If the signs are different, the answer is negative. So that is for multiplying and dividing. Be careful. Sometimes some students will mess up these rules and mistake them for adding, subtracting, etc. Multiplying and dividing follows these rules, so just be careful. So, example 9. You have 9 times negative 3. So you have a positive number and a negative number. So that automatically means that the answer is going to be negative. Then 9 times 3, 27. So negative 27, done. Negative 27 finished. Example 10. Negative 3/4 times negative 2 over 9. So that's a negative times a negative, which is positive. So now you just multiply the fractions. So remember, when you multiply two fractions, you're just multiplying straight across. 3 times 2 is 6. 4 times 9 is 36. That can be reduced. 1 over 6. So positive 1 over 6. So remember, the plus sign is not necessary. So you don't need to write the plus sign. Positive 1 over 6. Example 11, negative 48 divided by negative 6. So that's a negative divided by a negative, so that's positive. 48 divided by 6 is 8. Positive 8. And lastly, negative 35.86 divided by 11. So you have a negative divided by a positive, which means your answer is going to be negative. Now you're simply dividing out the numbers. So 11 can't go into 3. 11 goes into 35 3 times. That's 2. Bring up the decimal, bring down to 8. 11 goes into 28 twice. Subtract, you have 6. 11 goes into 66 6 times. Leaves you with 0. So negative 3.26. So the key point with multiplying and dividing, you simply multiply or divide. Same way you've been doing. Only difference is if the signs are the same, your answer is positive. If the signs are different, the answer is negative. Only things that are different. So we have looked at the computational aspects of adding, subtracting, multiplying, and dividing. We'll wrap up this particular lesson with looking at integers. So again, that means with these word problems, some of your answers will be negative. And the negative indicates something. The negative will indicate something. So keep that in mind. So let us begin with problem 13. A submarine starts out at 135 feet below sea level. It dives 239 more feet before stopping. Represent the current depth of a submarine as an integer. Let's see. So a submarine starts out at 135 feet below sea level. So below sea level means you're under the water. So if you think of the water, as being 0, if you're below sea level, that means that's a negative number. If you are above the water, that's positive. So 135 feet below sea level means negative 135. It dives 235 more feet before stopping. So if you're already below sea level and you're diving farther down, that means you're subtracting more feet. You're going lower into the ground. So that's minus 239. So now we're trying to figure out what is the current depth of this submarine. So we're solving out negative 135 minus 239. So to solve out this problem, we follow our rules for subtraction. Keep the first number, change subtraction to addition, then change 239 to its opposite. So you have negative 135 plus negative 239. Both numbers are negative, so we add them up. So it's 14,147.3. So that's 374, negative 374, and that's feet. So negative 374 feet means, in this case, 374 feet below sea level. So when you are working with negative numbers, it's not enough for you to just give the answer. You need to know what that answer means. Interpretation of a number. You need to know what that number means. If you just give negative 374, you also have to be able to tell us, well, what does that mean then? So example 14. An investor reports that his stock portfolio loses $12.60 per day. If the portfolio reported losses for 8 days straight, represent the amount in losses as an integer. So they're losing $12.60 per day. So losing money is something that's negative. So negative $12.60 per day. So each day they're losing that much. They reported losses for 8 days straight. So you could take negative 1260 and add it 8 times, or take negative 1260 and multiply it times 8. So we have ourselves a multiplication problem. Anytime you're repeatedly doing adding, that's what that ends up as. So we have a negative times a positive, so that means your answer is going to be negative. So all you have to worry about doing is multiplying 1260 times 8. 16 plus 4, that's 20. Remember, you have 2 decimal places that you have to account for. So that's negative $100.80. So how does that translate into real world knowledge? So this means a loss of $100.80. Again, we're representing it mathematically as an integer, but we still need to be able to interpret and be able to tell people what does that mean. So I have to be able to interpret and tell people what that means. So problem 15. The Stars basketball team was losing by 23 points at halftime. During the second half, the Stars outscored their opponent by 17 points. Did the Stars win or lose the game? By how much? Represent this number as an integer. So the Stars team was losing by 23 points at halftime. So that's negative 23 points. They're down 23 points. During the second half, the Stars outscored their opponent by 17 points. So that means whatever their opponent had, the Stars had 17 more. So plus 17. So we have to work that out to determine whether or not they lost the game. So it's an adding problem. So negative 23 plus 17, you have a negative number plus a positive number. So 23 minus 17 is 6. 23 is the bigger number, so the negative sign carries. So the answer is negative 6, which means that the Stars were losing. Stars lost by 6 points. So they mounted a nice comeback, but they weren't able to close the gap. They lost by 6 points. Lastly, problem 16. A reality TV show lost a total of 9,000 viewers over the past 6 months. If the show lost the same number of viewers each month, how many viewers was lost each month? Represent this number as an integer. So losing a total of 9,000 viewers will most likely get the show canceled. But a loss of 9,000 viewers, that's negative 9,000 over the past 6 months. So the key to this problem is the fact that the show lost the same number of viewers each month. So if you're trying to figure out how many was lost in 1 month, this becomes a division problem. Negative 9,000 divided by 6. So if we work it out, a negative divided by a positive is negative. So we work out 9,000 divided by 6. So 6 goes into 9 once. Bring down to 0. 6 goes into 35 times. Bring down to 0. 6 can't go into 0. And 6 can't go into 0. So that's negative 1,500. That's representing the number as an integer. What does this mean in terms of real life? So 1,500 viewers lost each month. So in a practical sense, that's what that means. Again, you can just tell someone negative 1,500, so I don't know what that means. But when you give it context, then we understand what you're talking about. So with that being said, that completes our review video for integers. So there's a lot to unpack here. So definitely take your time with it if you need to review integers. Just know integers makes up a big part of Algebra 2 trig. So you have to know how to add, subtract, multiply, and divide positive and negative numbers. So use the notes handout, use this video, and definitely work on the practice that goes with this lesson. And of course, ask questions as you have them. With that being said, I hope you have a great rest of your day, and I'll talk to you soon.